All right. So this one we're actually going to find how do we find a t-value, using our charts and tables before. Okay. So I can't emphasize as much, right? Quick reminder, try to put it in bold for you guys. Remember that this is the opposite of a z-score. So we will always be given area to the right of it. That's the key thing, right? So now, also one of the major things as well is when you find a z-score, right? I gave you the z-score, or someone gives you the z-score, and you can find the area. Now, this is very interesting. You're actually going the opposite direction when it comes to t-value. You will always be given the area. So you'll always be given the area, and you'll always be asked to find the t-value. Okay, that's the interesting part. So you'll be always given area and always being asked to find the t-value. So let's look at this example so you guys see what I mean by that. Okay, so it says find the t-value when n is 30 and alpha is 0.05. Okay? So we need two things to find a t-value. First thing is an alpha, which they just gave us right off the bat, so we don't actually have to find it. And next thing we need is a degrees of freedom. So degrees of freedom is n minus 1 or 30 minus 1, which gives us 29. Okay. Now, if we want to shade this portion, it always goes back over here. Remember, so this right here, this area is always the alpha given to you in this question. So if I want to shade over here, at some t-value, I know this area is going to be alpha, or in this case, 0.05. And now we want to find the t-value associated with that. Remember, you're always given area, always asked to find the t-value. Okay. Now, to find the t-value is actually not that bad using our tables. So if you have the tables popped up, or I'll pop it up here for you guys. So I believe it's on the third page when it comes to this, page 1, page 2, and then page 3. It says right on top, t-values. And again, notice they tell you area on the right tail. Unlike over here, when it comes to normal, it's area on the left tail. So it tries to give you guys a emphasis on when it comes to which one's the opposite as well. Okay. Now, unlike z-scores, where they give you, the actual markers itself, this one depends on the two numbers given to us we want. The degrees of freedom means you're going to go down the column, and the alpha given to you, you're going to go across the column and see where they intersect. That's going to be the t-value we're looking for here. Now, in our case, our alpha was 0.05 and our degree of freedom was 29. So we go to over here. Well, we have 29 degrees of freedom is down here. Right? And if we go across to the alpha given to us, 0.05, which is right there. And what we want to do is see where they intersect. So I believe they both intersect at this value right there. And that is the t-value we're looking for this problem. So our t-value is 1.699. And that's how we find a t-value using our charts. Pretty simple, right? Not too bad when it comes to it. But again, right, the main thing is when it comes to graphing and shading is if your professor, or if I want it, is alpha is always the area and the marker is the t-value, just like a z-score, right? Okay. Okay. So why don't we try some examples out? Okay. So why don't you guys try these two out? So here's the first one, and here's the second one. So find the z-score associated with these two. So I'll show you again. So this one and also that one. So go ahead and quickly pause the video, and we'll come back and do it together. Pause. Okay. So let's see. So first off, right, we need two things to find it. We need an alpha and degrees of freedom. So again, alpha is already given to us, 0.10. And degrees of freedom in this case is going to be 12 minus 1, which is 11. Okay. So we know, right, this is where I'm shading because it's always area to the right. So this is going to be 0.10, 0.10. And now we find the marker, right? That's going to be the t-value we're looking for. So if we go to our formula sheet, alpha being 0.10 and degrees of freedom is 11. So our t-value we're looking for should be 1.363. And there we go. That's how we find a t-value. Okay. Right, so on to the next one. So again, alpha is given to us to be 0.05 And degrees of freedom in this case should be 13 minus 1, which is 12. So if I shade again, and then again, finding the t-value, and if we go back to our former sheet, 0.05, and degrees of freedom of 12 this time, should give us a t-value of 1.782. And there we go. Right, so there's one more. Let me get back to the page right now. One quick more if you guys want it. So find the t-value when n is 100 and alpha is 0.10. So you guys can just do it in the back. So you can just quickly pause it and try it. And then we'll do it together right now. So I just put it in the back. So alpha again is already given to us, the 0.10. And degrees of freedom in this case is going to be 99, right? 100 minus 1 is 99. Okay. So here's my shading portion. So going back to our former sheet, so 110 is over here, and going down to 99, and if you notice, we do not have 99, right? So after 40 goes by tens. So what you want to do is you want to, round to the next one we actually have because it's not completely filled out. So in our case, since we have degrees of 99, well, 99 is closer to 100 than 90, correct? So we're going to round to 100 and use that value ourselves. Okay. So back here, this is 110 for alpha, and go to 100 in this case because that's the closest degree of freedom we have. So our t-value is going to be 1.290. And that's how we find t-values when it's not exactly, degrees of freedom when it's not given to us itself. Okay. Right, so nothing too bad when it comes, right? So hopefully that's a little straightforward and then, very easy, a little easier than z-scores. All right, so what I want to do now is just quickly summarize what we have so far before we go any further, okay? So now that we have some understanding of the two types of distributions, right, a normal and now a t-values, let's review a little bit here, okay? So when we're talking about population proportion, our parameter is going to be p, so that's going to be estimating, right, the entire population. So this is population parameter. Our point estimate is going to be p hat. Okay. Our distribution is going to be z-scores, right, or the normal distribution. Okay. Now let's go over here for mean. So when we talk about population parameter is going to be mu, right? That's our entire population parameter. Our point estimate is going to be x bar, right? That's the sample. And our distribution is going to be t-values. So that's what we mean by it's very similar to one another, right? The only difference is going to be these two when it comes to finding those things. Okay. Now, if we go back to the definition of the margin of error, this is how it's supposed to be. So this is how we're going to construct the confidence interval. Okay. Notice all we're doing is adding and subtracting e to our point estimate, meaning we're going to do add and subtract to this number or to that number respectively what we're using. That's it. That's all we can do. So that's how we construct a confidence interval. Once we find this margin of error, this number here, all we're going to do is add it to our point estimate, meaning either to that number or that number, depending on what situation we're actually in. Now to do this mathematically, here it is right here. So this is for proportion, right, because we have p's, p hats, and this is for mean, because we have x bars and means. And then right, this is in the middle because that's going to be bound between, so we're, it's roughly between these two numbers, but we can't be exactly correct. Okay. So now the question becomes, how do we find that e? So what's that, margin of error going to look like? And that's where these equations come into play. So these are two equations for margin of error respectively. Okay. So if we're talking about proportion, this is going to be our margin of error equation. If you're talking about mean, this is going to be our margin of error equation. Okay. So again, notice the z-score and the t-value, right, respectively when it comes to those kind of things. Right. Now, I have some good news for you guys when it comes to it. Now, when it comes to this z-score, remember, this is a z-score, this is a t-value, right? This is an actual value. So This is the t-value we did, we did above. Now, when it comes to this is z-score, which is pretty nice. You actually don't have to find it, because if you guys go in your formula sheets under the z-score portion and you look way under here, they already do that for you. So they give you the 4 major confidence intervals you actually always see in real life, and then pretty much for your homework as well. So if you have a confidence interval of 90%, the z-score that would go into that equation would be 1.645. If you have a confidence interval of 95%, that z-score you're going to put that equation be 1.96. So depending on what percentage you have, that number will be literally put into here respectively, right? So you actually don't have to find it, unlike a t-value where we do have to find it, right? That's where you have to use the twos different, right? The alpha, the degrees of freedom. This one, all really have to look at is how confident you are. Go on your chart, and that number, that z-score, goes right here. Just insert for that equation there. So it's a little easier when it comes to this one to that one, but we'll figure out how that portion becomes a little bit. Okay. All right, in the next video, we'll do some examples so you can see how that would work.